Another tutorial here under momentum and impulse tutorial 2. Here is a question. An 8-gram bullet is fired horizontally into a 9-kilogram cube of wood, which is at rest, and it sticks into it. All right. Now, the cube is free to move and has a speed of 40 centimeters per second after impact. Find the initial velocity of the cube. So, this is a conservation of momentum in case you are not aware. This is conservation of momentum because we can say that there's something initial and something after happening. All right, so according to the conservation of momentum, it says that momentum before collision is equal to the momentum after collision. Now here's the thing. If this is a bullet moving, right, then it finds a cube wood, all right? Cube of wood. So this bullet here, so this is a bullet and this is a cube of wood. So it has got its own initial velocity and it also has got its own mass. So we can call this as mass of the bullet. This, okay, also has got its velocity initial, okay. It also has its own mass of the cube. Now, after they collide, they are saying they stick together. Now, when they stick together, they are forming one system. Here there are two systems, system A, system B. But when they collide, so this is after impact. So after impact, they collide, meaning the cube, okay, the way the cube is, it now contains a bullet inside. So I'll draw this for you to see properly the pictorial representation. Okay. So the bullet now, here now we've got the bullet, okay, plus the cube as a single system. Here we've got this system A, and here we've got system B. This is before. So this is after impact. Now you can see that according to conservation of momentum, so momentum before impact is equal to momentum after impact. Okay, so now momentum before impact, it is the sum of the system A and system what? B. So there's momentum for system A plus the momentum for system B being equal to this system. Let's call it system C. Plus is equal to the momentum of system C. Remember that system C is now a combination of the bullet and the cube because now they have stuck together. So the momentum of the bullet, let's call it let's say initial, let's call it mass 1. Therefore, then remember it is fired, it's horizontally, meaning it is in the positive x-axis. So we can call this velocity 1 in the x, plus here we have the mass 2, okay, multiplied by the velocity in the x. This is the velocity of the cube. This is equal to, remember that these two, when they stick together, meaning their mass is also combined. So we've got mass 1 plus mass 2. Now, these two, remember, they have the same momentum. So we add the mass, meaning they also have got a common velocity. This is Vx. So we're looking for the initial speed or initial velocity of the bullet. So let's now substitute everything. So here we have the mass. Now remember that the mass should be in kilograms. So this gram should be what? Should be divided, of course. Okay, so here we have, of course, divided by 1000, we get 0.008 kilograms. The velocity we don't know, so let's call it V1x. Or we can just call it, let me do this, let me call it B. This is a bullet, this is a cube. Yeah, let's be specific. And this is a B and the cube. I think we are okay now. All right. So VBX we don't know. Plus, now remember, what about the momentum? of the momentum of the, so let me do this here, also here, also here. Oh no, here is fine. Eh? We said system A, system B, system C. We know which one, system A, system B. Fine. Okay. But the momentum, this one, which is for the cube, remember that the cube is at rest, meaning velocity is 0. So is its momentum. So the mass is 0.008 plus 9 kilograms. Then velocity, the final velocity is here, 40 centimeters. Now this should be converted to 40 meters per second. Just divide by 100 and then you get 0.4 meters per second. Divide by 100. So of course here, what are we getting? We are getting a 0.008 VBX is equal to, here when you add, then you get 9.008 times 0.4. So already here you can see we have to divide by 0.008, divide by 0.008. So our velocity Bx, which is the initial one, okay, so I'm getting 450.4 meters per second. So this is the initial velocity of the bullet when it started moving. So the principle of conservation of momentum here comes into play, very clever, and you can see how it has actually been applied. Don't forget to subscribe and follow for more.